Okay, so now we're going to take our knowledge of 30, 60, 90 triangles and incorporate that into finding the sine and cosine of these angles on the coordinate plane. So we're going to be using the knowledge from last time with sine and cosine with 45, 45, 90-degree triangles and incorporating that, but instead we're using a 30, 60, 90 triangle. So if we remember, these are two versions of our 30, 60, 90 triangle. And again, we're using the smallest side being 1 as opposed to anything else being 1. So in this case, we're using the one that's across from the 30 is 1. So in both ways, it's 1. Across from the 60, remember, is square root of 3. So again, square root of 3. And then across from the 90, we have 2. So across from the 90 is 2. So take a minute, refresh yourself over these triangles, and then we're going to see how we can use them. So when I'm looking at these, so if I'm doing sine, cosine, and tangent, or not tangent, sine and cosine of 30 and 60, the first thing that we're going to do is draw them. So when I have a 30-degree angle, I know that's in the first quadrant, and I drop this down. What this is this in here is 30 degrees. Again, that's my reference angle. So across from 30 is 1. So that tells me this is 90, so this guy up here has to be 60. So this is root 3, and this is 2. Again, keeping in mind SOHCAHTOA, our best friend. Sine is opposite over hypotenuse. And again, this is our reference angle. So this is where we are. Before, you might have noticed with 45, 45, 90 triangles that the answer was pretty much going to be the same regardless. It was going to be root 2 over 2. Whether or not it was positive or negative, you had to figure that out. This time, things are going to change. So when I have the 30 degrees, I go across and I see that I have, so sine of 30 is opposite, which is 1, over the hypotenuse of 2. So sine of 30 degrees is 1/2. If I were to look at the cosine of 30 degrees, again, I'm in the first quadrant. Here's 30 down here. When I drop this down, again, this is still 1, this is root 3, and this is 2. You don't have to draw all this into your triangle, but for practice, let's do it. Cosine, remember, is adjacent over hypotenuse. So if I'm sitting here, this is my adjacent, and here's my hypotenuse. So the cosine of 30 is the square root of 3 over 2. Now you can tell right away that these two things are not even close to being the same. So now you can tell that things are going to be a little bit more difficult. Why don't you take a minute and see if you can come up with the sine and cosine of 60 degrees. First thing to note is that you correctly labeled your triangle with your 60 degrees as your reference angle, which would change the positioning of your 1 and square root of 3. So instead of having, like in this problem over here, where we had the 30 degrees, we had the 1 across from it, that's going to happen here too, except the 30 degrees is this triangle, or this angle. The 60 is our reference angle, so across from the 30, now the base is going to be 1 in both cases. So when we do this, and I find the sine of 60, I go square root of 3 over 2, and then for the cosine, I see that it's 1 over 2. And you might notice a pattern, that the sine of 30 degrees is equal to the cosine of 60. So you might notice these are the same and these are the same. And that's going to be true as let's say the absolute value. Remember, sines are going to come into play in a bit when we switch out of the first quadrant, but for right now, you'll notice that these are the same and these are the same. Okay, take a minute, see if you can just graph these in the correct quadrant, and then you can go ahead and figure out what the sine and cosine of them are respectively. Okay, so you might have seen it when we graph these two, that I have 120 degrees, which is in the second quadrant, and my reference angle is 60 degrees, because that's what gets us here to being flat. So I've made here a 30, 60, 90 triangle. Here it's a little bit harder to see, but if I have my triangle here, this angle right here is at 5 pi over 6, so I'm pi over 6 away. Now, one thing to keep in mind is before, when we saw pi over 4, that automatically told us that it was 45 degrees, right? Because that was half of a half, so half of 90 is 45. Pi over 6 and pi over 3 are going to be the ones that you see most often here. And actually, they tell us a little bit. If I were to take pi over 6 and multiply by 180 over pi, I end up with 30 degrees. So this is 30 degrees. If I take pi over 3 is equal to, or multiplied, not equal to, if I take pi over 3 times 180 over pi, I end up with 60 degrees. So the way that I remember it, and how maybe a good way to help you, pi over 4, that's a fourth, right? That's 45 degrees. Pi over 6, hey, the 6 and the 3 and 6. So a 3 and a 6 always have to be together. So if you see a 6 here, you know it's going to be 30 degrees. Plus, that can also tell me, too, that pi over 6 is smaller than pi over 3. So this angle has to be smaller than this guy. So that's just the way I remember it, is by recognizing that a 6 and a 3 always have to be together in some kind of pair. So pi over 6 is 30 degrees, so sometimes it's helpful to write that really small on the inside so you don't forget. So now if we were to label these sides, you would see that this is 1 square root of 3 and 2, and this is 1 square root of 3 and 2. But we know we're in the second quadrant, so signs are going to come into play. When I'm progressing up and the y, so when I move up, these have to be positive values. But when I move left, all of those values have to be negative. So this becomes a -1 and this becomes a negative square root of 3. So sine of 120 would be equal to, if we keep in mind our SOHCAHTOA, sine is opposite over hypotenuse, so opposite over hypotenuse is square root of 3 over 2. If we do the cosine of 5 pi over 6, well, that's adjacent over hypotenuse, so negative square root of 3 over 2. So take a minute and recognize how these are similar and different, and just note that. Okay, why don't you guys take a minute and work on these last 4 problems by yourself, and then we'll come back together and see how you did. Okay, so first things first, you should have recognized with cosine of 220, you would find that graphed here with a reference angle of 30 degrees. You'd find the sine of -120 by going this way, so it'd be graphed here, and here's our reference angle of 60 degrees. Negative pi over 6 would be going this way with a reference angle of pi over 6, and then 5 pi over 3 would be graphing it all the way this way with a reference angle of pi over 3. So take a moment and check that you have all those correct, and now let's see if we can figure out what the side lengths are for each of our triangles. Okay, hopefully you got all the signs correct. You should see that this is -1 and this is -3. Here across from the 60 is negative root 3. Here is -1. Pi over 6, if we remember, that's 30 degrees. So if we write 30 degrees in here, then across from the 30 is the smallest, so that would be -1. And then this would be square root of 3. And then again, pi over 3, we can think about that as 60 degrees. So across from the 60 degrees is our negative root 3, and then we have a positive 1 over 2. So take a moment and see if you can figure out what the sine, cosine of all of these are. Okay, hopefully you found out that the cosine of 210, that's adjacent over hypotenuse, negative root 3 over 2. Sine of 120 is opposite over hypotenuse, so negative root 3 over 2. We have the sine of pi over 6, so that's -1 over 2. And then the cosine of 5 pi over 3 is 1 over 2.